All right. So over the break, it was Christmas time, and so we sort of did all the Christmas things. My mom passed away about a year ago, so this was sort of a big Christmas for us because it was our first Christmas without her. Uh, that's my dad in the lower picture on the left, and so it was a really big deal for him. It was kind of a sad time, but he came down and we made Christmas cookies, and we always make pizzas on Christmas Day, so we made pizzas, and he helped with that, and he had a lot of fun. And that was his first time to ever make Christmas cookies with us, and he made some really nice Christmas trees. I call them Christmas cookies, but usually we do a lot of dog bones because that's sort of our favorite cookie cutter out of the whole bunch. So we get a lot of dog bones. Uh, these are my kids. This is Ada and Micah. Oh, and that's my wife up there. So probably, oh, she teaches astronomy, so some of you might have had her for astronomy. It's a really great course, I understand. Um, these are our kids, Micah and Ada. Micah's soon be 9, Ada soon be 6. This is me. I had a beard last semester. I shaved it off over the break. Um, but our kids were in a Christmas pageant at our church, and Ada was Mary, and this kid was like some guy named Chad, which is also my name, so that's why we took a picture together, because it's like Chad and Chad. He thought it was really cool. Um, oh, we also went to Kansas City. My wife is from Kansas City, and my mother-in-law lives there now, so we went there soon after Christmas. It was really, really cold. Like you think it was cold here, it was super cold there. It was like 0 degrees. Uh, we went snow tubing, which was a lot of fun. We did a lot of stuff, though I was sick most of the time. Over the break, we rode our bikes a lot. We like to ride bikes. Like my whole family likes to ride bikes. We have like 10 bikes in our family. But that's our tandem. That's sort of one of our recent bikes that we've gotten. It's a tandem recumbent. So it seats 2 people. Um, sit back. It's a super cool bike. Let's see. Also over the break. Oh, these were my Christmas gifts that I received. So I got a pipe clamp. You might know what a pipe clamp is. It's sort of like a vise that you put on galvanized pipe. So I got a pipe clamp. I got a rolling stool. I got this shirt. My mother-in-law gave me this shirt, though I don't really look like that in it at all. It's like this really fancy, I don't know, athletic shirt. My wife gave me this CD. This is Laura Mvula. She's a British soul singer, really good CD. And then my wife also gave me some reflective tape to put on my bike so that people don't run into me at night. Okay, that's what I got for Christmas. Let's see. Oh, this is sort of what's going on this year for me. So, like, apart from sort of class and what have you, these are some things that are going on for me this year. I'm working on my MDiv at New Orleans Seminary, at the Baptist Seminary in New Orleans. So I'm taking a class this semester on the Old Testament. My little boy just started Cub Scouts, and we're doing the Pinewood Derby in probably a couple weeks. My wife and I are going to a conference in Flagstaff called Cool Stars. We're both astronomers. I study star formation, how stars form, and this Cool Stars conference is all about cool stars. Cool stars are low-mass stars, are very, very young stars. So we're going to go out to Flagstaff, and while we're in Flagstaff, we're going to leave there and rent an RV. My whole family's going, and we're going to drive up into Utah for like 2 weeks and just visit all the national parks. You might ever been to Utah? It's really pretty there. It's very nice. Summer or winter, it doesn't matter. It's a really nice state. So I'll go check that out. I think that's the end. Let's see, I also like to, on the first day, have an interview time. Because I really want to get to know y'all, and hopefully I'll get to know you as the semester goes along. But it's not really practical for me to interview you all right here. So we'll just take a few minutes, and you can interview me. Now, these aren't questions about the class. I'm going to give you about 3 to 5 minutes. Not to ask questions about the class, that'll come in just a bit, but just to ask questions like an interview, like on one of those television talk shows, like, what's it called where all the women, they sit around the table? Talk, or The View. Yeah, so, all right, y'all ready? Go. Yeah. Oh gosh, I don't know. I have a bachelor's of science and a bachelor's, a master's, and a PhD. Yeah, that's all. But I was in school for a really long time, like 12, 15 years. So I really like school. I'm really glad to be back in school because I love school. I thought that being a professor would be a lot like being in school, but it's not really at all. All right, what else? We could just sit here and look at one another for 5 minutes. She is, yeah. In fact, I had this beard. I saw y'all, the might have seen it in the picture. She was really upset when I shaved it off. She really liked it. I'm not sure that my wife liked it, but she really did like it a lot. She started crying when she came in and I'd cut it off. Yeah. What else? Morning. What? We like to travel, yeah. We're planning this trip out to the west, out to Utah, and then we're hoping to go to Washington, D.C. We've lived there. My wife and I both live there, but we want to go out there and sort of visit all the sites. Just a second, I'll get you next. Um, I guess other trips. My wife's family is from Finland. Like her mother is from Finland. She was an exchange student and immigrated to the U.S. and when she was a teenager. But she still has some family over there. So we've been to Finland. Well, she's been to Finland a bunch. I've been there once, but we hope to go there again in a few years. I'm 37, soon be 38 in May. May 27th is my birthday, actually. Oh, you're right. Yeah, okay. All right, what else? Yeah. I'm from Mississippi. My dad still lives there. From near Quitman. Oh yeah, I know Shavuta. Yeah. And my dad actually lives out in Carmichael or Crandall community. So Quitman is this little small town of like 5,000 people maybe. I don't know. Shabuta's even smaller. And he lived about 20 miles, or I lived about 20 miles out of there. But then I went to high school in Columbus. I went to the Math and Science School. Louisiana has a similar thing. And then I went to college at Mississippi State in Starkville. And then I went to Austin, Texas. You have a couple more? Like wherever I live. Like right here is my favorite. I love Thibodeau. It's really nice. But I really loved Austin. Weather's nice, yeah. I like warm weather. I'm a pretty content person. I don't really have a wherever I live is my favorite place to live. Is that fair? I could die here and be perfectly happy. All right. All right. One more question. This is going to be like the clincher. Yeah. My favorite planet. I don't really have a favorite planet. I'm sorry. Jupiter's pretty cool, I think. I remember about 10 or 15 years ago, a comet crashed into Jupiter, and it was like a superstar, the planet Jupiter, because everybody was looking at it. Because when this comet crashed into Jupiter, it shot up all a big plume of gas and all sorts of stuff, and they were able to study Jupiter really closely. So that's kind of cool. I like Jupiter. It's the biggest too, and it has that big red dot on it, which is kind of cool. All right. Anything else pressing? One more? Okay. Pastime? I like to ski and I like to mountain bike, but they're pastimes because I can't really do them around here. So we can sort of mountain bike a little bit, but I've taken the knobby tires off my bike and okay. All right. If you ever have any questions, just let me know. I want to go over the syllabus quickly. Um, I sent I sent most of you probably got it unless you registered late. I sent you a link to the website in the past couple of weeks or so. If you didn't, no worries because it's on the Moodle site and there wasn't really I sent out the book and stuff, which I'll go over now. Um, if you go to Moodle and you go to our course 151, you'll find there's a website here, the course website. If you go to that right here, this is our course website. Looks like this. It has a number of things on it. It says our syllabus. And I just want to go over that quickly. I know that y'all can read it, but I just want to hit some high points on it because they're fairly important. Um, this is the textbook that we'll use, the Physics of the Human Body. You can buy it on Amazon for about 20, 30 bucks. You can buy it in the bookstore. They had a mistake or whatever in the bookstore, but they have it now. If you've tried looking there, they do have it now. You can also get an iClicker there. Either the iClicker or the iClicker 2. I think they only sell the iClicker 2 in the bookstore, but the iClicker, if you have that, will also work. We'll use that for in-class questions and what have you. Um, We're going to cover all of physics in this course. So there are 8 chapters. We go from motion and Newton's laws, forces and stuff, all the way through radiation and what have you. I'm teaching this course differently and using a different book, so I don't really know how far we're going to get. So we might not get up to chapter 8, but I think we'll definitely get up through chapter 6, okay, through the optics of the eye. But we'll probably get through chapter 8 as well. All right, you will have 4 exams in this class. You'll also have reading quizzes. There'll be 5 quizzes, and each will be worth 50 points. I'll give you the first date for that quiz. Well, it's going to be, what's today, Thursday? Let's make it next Thursday. Okay, so our first reading quiz will be next Thursday. I'll tell you about the format for that soon. Our first quiz, our reading quiz, will be next Thursday. That's going to be Thursday the 30th. All right, these reading quizzes are going to be short. All right, they're going to be based on the chapter in the book. Usually I'll give them like soon after we start a chapter, but since not all of you have your book now, I suspect, then not all of you have probably read the chapter yet, but just read chapter 1, and I'm going to ask you some very basic questions from that chapter. They'll be either multiple choice, true, false, or short answer. Okay? It'll be short, 5 to 10 questions, just one sheet of paper, and that'll be worth 50 points. Now you will have 5 quizzes, but I'll drop your lowest quiz grade. Okay? But they should be easy ways for you to pick up points in the class. So just read the chapter once, and then maybe read it through again. Morning. In addition, you'll also need to select a chapter in the book and write a review about this. This review should be about 1,000 words. That's about 4 pages. It'll summarize the chapter, and it should also describe real-life applications of the principles in the chapter. So you can use other references in order to look at some of those applications, preferably in your own field. And we'll talk about a lot of those applications as we go along. How, Newton's laws, for example, will apply to athletic training or whatever. All right. If you don't want to write, you can also do a 5-minute presentation to the class, and we'll reserve time on the last day of class for that. Okay. So you can either write a 4-page paper, 1,000 words, or you can do the 5-minute presentation, 5 to 7 minutes or so. And that chapter review is worth 150 points. That should be an easy 150 points for you, okay? So I want you to take advantage of that. During the class, I'll also give you questions as we go along and pose multiple choice questions to you, and that's where your clickers will come in. These will be based on the material that we've just covered, and you'll receive in-class credit for that, 50 points for class participation. You'll get credit for incorrect answers, but then you'll get twice the credit for correct answers. So it's really meant for you to participate in the class and be engaged in the class. Make sure that you're following along. All right? I expect that almost all of you will get that 50 points. If you come to class regularly, I expect that you'll get that 50 points, even if you get a lot of the questions wrong. Generally, the rule is, or it's not a rule, but generally in my classes, if you get half of the questions wrong, but you answer all of the questions, then you'll get the full 50 points. Usually I give an actual value for the question, but I don't know how many questions I'm going to ask in this course because I'm sort of going along with y'all. Is that clear? We have several things that make up your grade. You have the exams, which are 400 points. Then you have the reading quizzes, which are 200 points. Drop the lowest grade. And then the chapter review, which is 150 points. And then class participation, which is 50 points. All right? So it's sort of spread out quite a bit. There's the grading, how I grade it. The makeup, if you miss an exam, then if it's excused, please bring me documentation of some sort. University absence, documented illness of some sort. Just come talk to me. We'll deal with it. If it's unexcused, you slept late, or you're just not ready for the exam or whatever, then I'm going to deduct 15 points from your grade. And then I'm going to deduct 5 points every day until you come see me. Okay. So it really behooves you to come on the day of the exam and take it, even if you're not really prepared for it. All right, there's the drop date, and if you cheat on an exam, I'll give you a 0 in that exam. Usually means an F in the course. All right? I don't expect that to be a problem, though. Any questions? No? All right, well, I really want to get to know you. And one way I get to know you is just sort of by knowing, your name. So I like to take pictures of all my students. Yeah, really. So we're going to take a few minutes. You know, y'all can sort of chat amongst yourselves, but if you see your name come up, then please come and stand. Just stand, you know, underneath your name. So like if I was Jessica Bailey, hey. All right, so y'all coming up. Guys, these pictures don't go on the internet. They don't go anywhere. I print them out and put them on paper. Oh, you're Jessica Bailey, huh? All right, give me just a second. Are y'all ready? 1, 2, 3. That looks good. Y'all come on. Hmm. All right. If your name comes up, come on up, please. Are you ready? 1, 2, 3. All right, good. Janae, would you mind clicking the mouse and going to the next page? See the little blue arrow down there where it says next? Valerie, Casey, Jenna, and Tori. Valerie, Casey, Jenna, Tori. All right, 1, 2, 3. And Tori, if you could click the blue arrow, please. Uh, Janae, am I saying that right? Who is that? How do you say your names, ladies? Dejanay? Dejanelle. All right. Okay. All right. 1, 2, 3. And Destiny, if you'll push the blue arrow, please. Talia, Brianna, Daphne, Shauna. Talia. No, Brianna. There she comes. Daphne. Shauna. Oh no, Shauna. Not yet. All right. 1, 2, 3. Very good. And Shauna, if you could press the blue arrow, please. Fazal, Rachel, Shannon, and Sydney. How do you say your name? I said it right? Fazal? No, Rachel? Oh, man. Sorry. All right. 1, 2, 3. All right. And Sydney, if you could push the blue arrow, please. Christina, Roy, Bryce, and Evan. No, Roy? No? All right. Christina, Bryce, Evan. All right. 1, 2, 3. All right. And Evan, if you could push the blue arrow, please. Push the blue arrow, the next arrow. Down there at the bottom. All right. Jesse, Paige, Cheyenne, and Reagan. Jesse, Paige, Cheyenne, and Reagan. All right. 1, 2, 3. And Reagan, if you'll push the arrow. Oh, yeah, I'm sorry. How do you say your name? Dejanay. And Elise. And how do you say Kiosha and Austin? Dejanay, Elise, Kiosha, Austin. Austin, if you'll push the blue arrow, please. Robin, Alexandra, Najane, and Tiffany. Alexandra, do you go by anything else? Alex? Okay. How do you say your name? Najane? Okay. Is Robin still here? No? All right. You ready, ladies? 1, 2, 3. All right. Tiffany, if you'll push the arrow for me. Alex. Right. Alex. Oh, yeah. Joshua. Alex. Elena or Alana? Alana. Joshua, do you go by anything else? Joshua? Okay. And Kylie? All right. 1, 2, 3. All right. Kylie, if you'll push that arrow for me. Was that the end? No. Dane, Macy, and Kayla. All right, folks. 1, 2, 3. All right. Thank you. So these will be showing up on the front Nichols page. The front of Nichols page. Yeah. Okay, don't worry about it. What is your name? Chelsea. I'll pick it up along the way, okay? But my wife put the camera in this purse so that I can carry it around, and then it looks like I have a purse. All right. I want to show you all a couple other things that were on the website. Whoop, sorry. That'll be useful for you. And we will move on soon and get started. So on this website, the syllabus, of course, you can find all the grading and all your expectations and what have you. There's an addendum here, various things, what we'll do in case of hurricanes or emergencies, or if you have grievances or need special compensation, then please read that. My office hours are here. My office is just around the corner. I'm usually available if I'm not in class. I have a few times when I go off campus, and I've labeled those here. But any of these white areas, you can also find me. If it's my office hours, just drop by. If you just want to drop by, that's fine too. But if it's not office hours, I might not be there, or you can make an appointment too. But if you need help in the class, that's one of the best ways to get help. Just come see me in the office. I can help you. There's also a good tutor in the tutoring center. Amber Moore is an excellent tutor. She's been tutoring physics for a couple years now. Let's see, this is the textbook. You'll need this for a variety of things. That you can get it on Amazon. Looks like it's $35.76, but you can get it for less than that for the used copies. Looks like they have used ones at $20. Now you will be using this book. I'll follow it pretty regularly, and then your chapter review will come from that, as well as your reading quizzes will come from that book as well. I think it's a good book. There's very little math in it, and we'll see very little math. A little bit of simple algebra, but otherwise just sort of basic. I'd like to remove math from this course altogether, but there is a little bit. There's a little bit, okay? So, also, if you look here, you'll find screencasts for this course. Now, this goes back to last spring when I offered this course, but I'll have like today's class up on this. So if you do have to miss class, you can catch up on the notes or whatever by looking at the lecture. And it'll just be sort of my audio, which is why I'm recording, as well as whatever's on the screen here. All right? So that might be useful for you, but you can't make up the class participation points through that. It's just if you miss. All right, and then also old quizzes. I've only given this class once, so I don't have many, but these are the quizzes from spring 2013. You might want to look at them, but your quizzes will probably be a little bit different, similar but different from these. Okay? More about that when we get closer to the exams and reading quizzes and what have you. These were their exams, actually. All right. Any questions about the course? It's a long time to do all that. Yeah, that's all? Yeah. There is a link on Moodle, right, from the course website on Moodle. It just links to this. I also sent an email out a couple weeks ago, or a week or so ago, and that link was in that email as well. All right. Any other questions? Y'all excited about physics? This is a pretty good course, actually. I think it's fun. All right. No, it's my second. Actually, it's my third. I taught it way back in '07. Uh, like, how did students do? Um, I think last semester, I think the class average was around a 75 or so. But I think I only had one or two people that didn't pass on from the course. So uh, there were there was a handful of A's and a lot of B's and C's. Okay. But I'm willing to give out all A's. Absolutely. Okay. I know Dr. Scott, Bridget Scott, she said there were an awful lot of C's in that class. Okay. Sorry. Um, okay. Come to class. If you have trouble, come see me early, not late. That's the key to making it in this class. Keep up with the reading. Practice outside of class. All right. Um, all right. So when you think of physics, what do you think of? If you were to say, "What is physics?" What would it be? So just what do you think physics is, or what is physics the study of? What is physics? What would you say? The study of what? Hmm? Okay, a big part of physics is the study of movement or motion, right? And we'll get into that a bit. The study of motion. In physics, we call that kinematics. And obviously, when you're concerned with the human body, there's a lot of motion involved in the human body, and we'll deal with that, how the body moves and how muscles in the body exert forces on the body. So, yeah, motion is a big part of physics, not just in classical physics. Classical meaning like the study of sort of big things that have been studied in the past couple hundred years, but also in modern physics when we study like small things like atoms and what have you. What else is physics the study of? Okay, forces, right? I'm sorry, who said that? Who said forces? You did. What's your name? Jessica. Okay. All right, so the study of forces, I'll lump that together with motion. And we'll get into forces in this first chapter. In fact, that whole first chapter is all about different types of forces. What else? What's physics the study of? That's a question. Okay, mechanics, yeah. That's also like the study of motion, what have you, or the study of forces. Let me write some of this down. I'm sorry, you said mechanics, didn't you? All right, what else? Okay, math, yeah, we'll deal with math in this first chapter. Missing some pretty big things. How about, huh? Okay, yeah, velocity, that's motion, yeah. What else? Sound, right? We'll deal with sound, and in particular, we'll look at how the human ear detects sound and how we measure sound, right? So sound, gravity, right? We'll deal with that in terms of forces and what have you. How about light, right? Like we'll look at how the human eye detects light and how we measure light. So we have the study of light, the study of gravity, the study of sound, somebody said. And let's see, leaving out one big topic here, which we'll also get to, which is the study of electricity. All right, so we're going to look at all of these sort of from a qualitative view. That is, we'll sort of see how these things respond and how we can measure these things. And so physics is really the study of the physical universe, the study of the physical world. I have a little clip here. I think that sometimes when we look at these things, like when we think about motion, for example, that we think, well, gosh, that's really simple, right? And really, what's the point of studying that? Uh, but I think that when we do that, that we really miss out on a lot. First of all, motion isn't really that simple, not really simple at all. And it's actually quite important to study, even if you're in like athletic training, for example, or if you're studying the human body in any way, because the body does move in a lot of different ways, in a very complex way. Um, Here I have a little TED Talk. You ever listen to the TED Talks? TED Talk, it's, I forget what it stands for, technology, entertainment, and something else. But anyway, they bring in speakers to talk about particular topics. We're just going to watch a minute or so of this from the very beginning. Um, all right, so I know that like many of you probably read, I want to take a physics course, right? Am I true in saying that? Yeah, very likely. But, you know, physics, there are a lot of unanswered questions. And despite the fact that it's applicable to what you're doing in studying the human body, because there's a lot of physics in the human body, also, just very simple ideas in the study of physics have led on to very profound discoveries in the world. So it's useful to just have a good understanding of that, even if you're never going to go work in a lab or go win the Nobel Prize or whatever. If you're going to be working with people as their bodies move and as they have injuries or as they are trying to learn new things about themselves, it's very useful to know how the body works and know how physics applies to that. So just want to encourage you that, you know, I think that people often when they come to a physics course, they either come to it with disdain, like they really hate it and they just don't want to be there, or they come to it with a fear. And I hope that neither of those states you find yourself in, that you're neither afraid nor you're hateful towards the course. Okay, so just know that these are simple ideas, but they can be very important. All right, we're going to look first in this course at some units, how we make measurements, and we're going to look at, in particular, how we make measurements in physics, which are called the SI units. So we're looking at physical units. This, by the way, isn't in your book, but I feel like you need a brief introduction to it because we're going to be using some of these units as we go along. So physical units, we're going to use a particular unit called the SI system of physical units. The SI system stands for Système International. I think it has an E on the end, it's French. It's the international system of units. Almost all countries adopt the SI system, except for the United States, and I think there's like a country in Africa that doesn't adopt the SI system. Do y'all know what system we use for measurements? What's that? No, not the metric. The SI actually is the same as the metric. So when somebody says the metric system, they also mean the SI system. We use the British system, which the Brits don't use anymore, but we use the British system. And the British system consists of things like pounds, ounces, feet, miles, that sort of thing. So in the SI system, we have three different measurements. We have length, we have mass, and we have time. And I want you to know the units for each of these. We also have a fourth one, which is charge, which we won't get to till the end of the semester, but I'll go ahead and list it here. I want you to know each of these. The unit for length is the meter, and we abbreviate that with a lowercase m. Now, a meter is approximately equal to how many feet? It's about 3 feet. It's about a yard. It's a little bit bigger than a yard. A yard is 36 inches, and a meter is a little more than 39 inches. But this is a meter. It's about the distance from the middle of my chest to the end of my arm. Okay, so this is a meter. So for example, like these tiles on the floor, they're about a meter. Actually, I think they're a yard across. But so that's a meter. We'll be using these in just a bit. We'll have a little activity to do with them. The mass is, the unit for mass is the kilogram. We abbreviate that with a K and a G. We're not going to try not to use many metric prefixes, but I do want to tell you that a kilogram, 1 kilogram, is equivalent to how many grams? Anybody know? It's 1,000 grams, yeah. We're not going to get a whole lot into converting between units, but it's useful to know that a kilogram is 1,000 grams. This is a kilogram. It's a little more than a couple of pounds. You can pass this around if you like. Is it 2.2? Yeah. All right, so a person has a mass of about 70 kilograms or so, 70, 80, 90 kilograms. Anybody know the unit for time, the SI unit for time? All right, it's the second. Everybody knows what a second is. It's abbreviated with a lowercase s. And then the unit for charge is the coulomb. We're not going to get to this for a while, but I'll go and list it here. It's a coulomb, and the abbreviation for that is a capital C. With units, if your unit is based on a person's name, the unit itself is not capitalized, but when you abbreviate it, the abbreviation is capitalized. If y'all care, that's just a little grammar for you for the morning. Okay. We have standards for each of these. So if we want to know what a meter is, we need to have something that we know is exactly a meter so that we can compare something. So if I wanted to measure my height in meters, I would get a meter stick. And this would be my standard. I would say, okay, I know this is a meter, and so I can measure my height. I'm a little less than 2 meters tall. Okay? So this is like a standard. But we have international standards in the SI system that define what a meter, what a kilogram, and what a second are. And I want you to have some knowledge of what these are. You need to know what the standards are. So the standards, that is, what is the meter based on, what is the kilogram based on, and what is the second based on, are like this. I'm going to get rid of this. The standard for the meter is the distance light travels in a certain amount of time. That amount of time is 1 over 3 times 10 to the 8th seconds. All right, the number is not important, but it's the distance that light travels in a particular amount of time. Light travels exactly 1 meter in that amount of time, in 1 over 3 times 10 to the 8th seconds. All right? That's a very easy thing to measure. It's very easy to measure the speed of light and to measure the distance that light travels in a certain amount of time. And so it's a nice standard for the meter that anybody around the world can use. The standard for the kilogram is a cylinder in France. All right, there is this cylinder. It's about this big, and it sits in a laboratory in France, and it is a kilogram. That's how we define the kilogram. And every other kilogram in the world is based on this kilogram that sits in France. We'll watch a video about this in just a few minutes, but it's actually a little more complicated than that. But you have this physical cylinder that we say, this is a kilogram. All right? That has some problems attached to it, which we'll cover in this video in just a minute. Time is based on the frequency of oscillations or of an oscillating cesium atom. All right. A cesium atom, a particular cesium atom, in fact, it oscillates back and forth at a very, very regular rate. back and forth, back and forth, back and forth. And you can measure the frequency at which it oscillates. How many times does it oscillate in a given amount of time? And we base our definition of a second on that frequency of an oscillating cesium atom. We say that 1 second, I think it's like 10 billion oscillations of this cesium atom. Okay? And let's not worry about the charge for the Coulomb. We'll get to that when we get into later chapter. All right, these questions will come up. We'll have some class participation questions where I'll just quiz you on these, and you could also see it on the next test. All right, let's watch a little clip. This is actually kind of a long video. It's about 10 minutes. I'll use videos throughout the class. I think they're fairly interesting, and they'll be related to the material that we'll cover. And usually they'll just be a couple minutes or so. This one's kind of long. It's about 10 or 11 minutes, but I think it's useful. It talks about the mass, the standard for mass, the kilogram, and the problems that are associated with having a cylinder as a standard for the kilogram, and then also efforts that are being done right now in order to create a new standard for the kilogram. Can anybody think of a reason why having a physical cylinder in France, why that would be a problem as a standard for a kilogram? Not many people can access this, right? They have, if you're French, you can go to this, well, not just any French person can do that, but you can go to this lab if you're in France. Now, they've tried to fix that by having sort of copies of this cylinder all around the world, but still it's inaccessible to some people. Like, y'all couldn't go out and see this cylinder. What else? Yeah, it's actually changing mass, and they'll talk about this in the video. So anytime you have just a single physical object, it can change. It can change. They don't really know why it's losing its mass, but presumably atoms are either jumping on or off of this cylinder. So it's changing slightly. And since it's a standard, it needs to be exactly 1 kilogram and to be unchanging. What else? Let's see. It's accessible. I think that'll be good. Let's watch this video now, and they'll talk a bit more about it.